So question number 1, diagram show the graph of fx equal to a cos bx plus c. X is between 0 and 8 pi over 3. Explain why f is a function. So this is a many to one relation. So to 1, as long as it is to 1, then it is function. So if you use the vertical line test, then it will touch 1 point on it. So uh, you can say that each value of x is mapped to a unit value of y. Then we want to find the range of f. So for the range of x, the largest value is 1 and the smallest value is negative 5. So the range will be the fx is between negative 5 and 1. Question number 2, we have the gx equal to 3 plus 1 over x. Find an expression for the g inverse. So let gy equal to x, then g inverse of x equal to y. So 3 plus 1 over y equal to x, 1 over y equal to x minus 3. So the y is 1 over x minus 3. So move up, move down. Therefore, the g inverse of x is 1 over x minus 3. And then the x cannot be 3 because x minus 3 cannot be 0. So x cannot be 3. Okay. So, okay. Hmm. Then we have to find the range of G inverse. So we know that the range of inverse is equal to the domain of G. Okay, so the range of G inverse will greater than or equal to 1. Okay, and we want to find the uh, domain for G inverse. So for this one, we know that 1 over x, the graph is like this. And then this is 1 over x. So plus 3, then we have 3 here, and it's like this. And when x equal to 1, then g of 1 is 3 plus 1 over 1, then it's 4. Okay, so we have 1, 4 here. And then go to infinity, the smallest value, infinity, then they don't touch 3, not don't touch 3. Okay, so we know that for the range, okay, so range for G, okay, from here we know that the range for G for this domain will be the G is between 3 and 4, include 4 but not include 3. Okay, so the domain of the uh, G inverse will be the x between 3 and 4. Okay, question number 3, fx is 5 ln 2x plus 3 and then the x greater than negative 3 over 2. Okay, when x equal to negative 3 over 2, then is non-zero undefined. So we know that the graph for ln is like this. Okay, so the range of f is real number, can be any value. Okay, yes. And then we want to find the f inverse and state its domain. So let fy equal to x, then f inverse of x equal to y. 5 ln 2y plus 3 equal to x. Then we have the ln 2y plus 3 equal to x over 5. 2y plus 3 is equal to exponent to the power of x over 5. then 2y is the exponent, and then minus 3. So y will be the e to the power of x over 5 minus 3, and the whole thing divided by 2. Okay, so the f inverse of x will be this. And x can be any value. We know that the domain of f inverse is equal to the range of f. Okay, range is real number, so this should be real number. Okay. And then on the axis below, sketch the graph of fx and the graph of f inverse. Label. Okay, so this one, okay, we have the x-axis and the y-axis here. Okay, and then we have the y equal to x is the axis of symmetry. This is y equal to x. This is x. This is y. And then we have the negative 3 over 2 is here. So negative 3 over 2 is here. So the graph, so this is negative 3 over 2, negative 3 over 2. And then we will have this also negative 3 over 2. Okay. So the fx is something like this. So this is the fx. Okay. So ln when x equal to 0, okay, phi ln 3. Okay. So f of 0 is phi ln 3. So f of 0 is phi ln 3. So over here is phi ln 3. Okay. And then the f inverse here. So this is the f inverse. So the f inverse of 0 is e0 minus 3 over 2. 1 minus 3, negative 2, then negative 1. So this is negative 1. Okay. Then we have the negative 1 here. So the graph for this will be something like this. So this is negative 1. And then this is phi ln 3. Okay. So this is the asymptote. Okay. The negative 3 over 2. And this is the asymptote also. Vertical asymptote, negative 3 over 2. Okay, so fx, and then this is the f inverse of x. Yes. So if we check the answer using Desmond, we have the phi ln and then 2x plus 3, and then we have the e to the power of x over 5, and the whole thing divided by 2, and this minus 3, and then minus 3. So we have the y equal to x here. Yeah. Okay. So for this one, we have this and this, and we have the x equal to negative 3 over 2, and then we have the y equal to negative 3 over 2 is the asymptote. Okay, then this 2 point here, and we have the this 2 point here. Okay, yes, this is how it look like. Yeah. So this is provided. Okay, assist is provided. I don't know. Okay, never mind. Lesson number 4. Write down the largest possible domain for this function. So the 2x minus 1 is greater than 0. So the x greater than half will be the domain. Okay. Hmm. Next, find the F inverse and its domain. So let Fy equal to x, then F inverse of x equal to y, then for ln 2y minus 1 equal to x, then we have the ln 2y minus 1 equal to x over 4. 2y minus y is e to the power x over 4. Then the 2y is e plus 1. Then y is the e plus 1 over 2. Therefore, the f inverse of x is e plus 1 over 2. So we know that this one is like this. So the range for f is the f is real number. So the domain of f inverse is same with the range of f. Therefore, the x can be any real number. Okay. Hmm. So half e power x over 4 plus 1 real number. Yes. Question number 5. Hx is this. Intersect y equal to x at two distinct points and on the axis.